So for this topic that we begin today, let's look at the chain rule. That's one of it. It's another universal rule that we want to learn over here, and very useful rule over here. Important rule to learn actually as well. So before we learn precisely what the rule, the chain rule is all about, let me bring in a problem like this. So it's in these days now, it's starting since last week, it's all about we want to find a general derivative, right? Some kind of function that represents the slope of the tangent line anywhere at any given x value, right? So it's been that work that we keep getting further and further, deeper and deeper into. So how about we're given a function like this, y equals, there's in parentheses 2x squared minus 4, and we raise it to the square power, for example. Okay? And then so our simple instruction here, let's find the derivative of y dx. Clear with that right there? Okay? And so think about this one right here. Allow me to speed up the process with this one right here, because we've done a lot of power rules and all that, right? And so with the problem like this, we got the power 2 right here, but it's, inside of that power 2, there's the 2x squared minus 4. So I'm talking about before finding the derivative, we can purposely rewrite that as think of that as a 2x squared minus 4, and then 2x squared minus 4, multiply again, right? And then we take our time foiling. That's how it has been, right? Because we at this point we haven't learned too many rules yet. Like 3 universal rules and then 1 power rule specifically for powers, right? That's why for something like this, we're in a situation like this, we've got to FOIL out. So 2x squared with 2x squared, and 4x squared, you guys agree? Okay? And minus an 8x squared, right? And minus another 8x squared right there, and plus a 16. So combining the like terms together, our final function here before taking the derivative, right? It's going to be a 4x squared. I mean, x to the 4th, it should have been here. Okay? X to the 4th. Okay? 4x to the 4th. And then minus 16x squared, right? And plus 16 right there. Right? So we turn our function, we did our foiling, and we turned our the function into a function of 3 terms with power terms, right? Each term here has a power and a coefficient. And this is where we can use a derivative. We can calculate the derivative easily. Like, see, term by term, the first term gives me a 4 times 4x cubed right there. You guys agree? Okay. And then minus, and then the 16 is the coefficient multiplied with 2x, right? For the derivative of x squared plus the derivative of the 16 is a 0. Sounds good? Okay. And so that way our final derivative is a 16x cubed minus 32x. You guys all agree with me on that? Okay? So doing it this way is not anything surprising, right? Doing it this way is really nothing surprising at all. Let me bring in a situation. I'm talking about the way how I'm seeing this function here. And the work we handled that was a foiling work, right? There was a 2x minus 4 and being put inside a high power. Right now I'm calling that a high power, but really isn't that high yet. It's only a power 2 right here. That's why the foiling was okay, right? The foiling was okay. Think about it, put it in a what if situation. Talking about what if, right? What if the same 2x squared minus 4 here being raised to a really high power, like a 100? Like, raise your hand if you're patient enough to FOIL that 100 factor. Okay? I don't want to try it, right? But see, a situation like this is similar to that. But just unfortunately, the power is too high, and that naturally rules away the choice of going through the foiling. Right? Even though you could, but it's going to take forever. See what I mean? And so we're going to roll back to this problem here. Okay? So foiling for this, right? It's out of option, right? It's not an option any longer. So we're going to roll back to this and analyze this a little further. So we're thinking about, hey, is there another way to directly handle this without the foiling? See what I'm saying? Otherwise, foiling, at some point, we're going to have to give up foiling. Right? So being able to find a derivative using foiling, that's the end of the story already. The way how I'm seeing this now. So let's say we roll back to this same problem, back at the beginning point. Let's make some observation. So I pointed out right here that the 2x squared minus 4 being put inside a power, right? Being put inside a power. I'm starting to use that term here. So why don't we define separately a function g of x here? Just 2x squared minus 4. You guys following? Just 2x squared minus 4. I see that as some function g of x. So the whole setup right here, the entire y equals 2x squared minus 4 all squared here can be understood as the g of x, right? And then being squared again. See what I'm saying now? right? G of x, then the h squared, right? But wait a minute, g of x, the h squared, so now because we already kind of like, the whole reason that we let the whole thing here being g of x so that we can have a more, sort of like a more general look at the entire picture without being too worried about the 2x squared minus 4. So now kind of like we diminished our attention on that a little bit, but having a better attention to the entire structure, I realized that, hey, there is a function. There's a function capital F of capital X somewhere being the x squared function. You guys seeing that then? The whole thing that here I'm seeing see whatever that is we regard as a capital X variable. And then we square the whole thing. So this function f all of a sudden we realize, hey, we call that. I mean, naturally enough, you can see that it's put outside, right? Outside of your g of x function. You see what I'm saying? So that f of x here, see, so the g of x, let's call that as the inside function, right? Because it's inside the power, and then here the outer function that applies on top of the g right here, we call this whole thing the outside function. See what I'm saying, no? And so picking up from that right here, the whole y of y equals 2x squared minus 4 all squared here, we can understand that as f of g of x. Once we have defined g separately as that 2x squared minus 4, right? And then the y here, the y is, we recognize it as a squaring function being that capital, that f of capital X. So in the end, the whole function y that we've had at start is just the function g that we place it inside of our function f. We substitute that in. So the idea is back from pre-calculus 1 that it's a composite of two functions, right? F composed of g. You guys good with me on that? Okay? So that's just beating around the bush to help you recognize the structure of our function, where it came from. Okay? And really, the inside or the outside, a lot of times it does take some experience to get there. So I promise that when we get into doing some example, I'll design those that go from the easy to harder levels for you guys to recognize the inside and the outside. But then here's the thing. So from now, under my lead right here, I showed you that I recognize the g here as the inside and that there as the outside. Back to the problem here. The whole problem we're doing, 2x squared minus 4, right? All squared. One whole combined function. Now, our goal is to find the derivative, right? I point out about the outside and the inside, especially right at this point here for a purpose. You see, if we just pay attention to, we only need to pay attention to the 2x squared minus 4 as one big variable. And here we got a power 2, right? You guys follow with me right there? Once again, all I'm saying is instead of paying too much attention into the whole 2x squared minus 4, I'm only seeing that as some general variable. I call that a g, or a capital X, right? And then in that way, after we kind of diminish the attention on the inside, then the whole structure here, I see a power 2, right? So power rule kicks in, right? The power rule, for taking derivative, the learn kicks in. So that means what? Think about it. Power rule says what? We multiply the 2 down, right? We multiply the 2 down, and we keep the whole big variable the same. The whole big variable, what's the whole big variable? 2x squared minus 4. You guys follow with me on that, okay? And then the rule, the power reduced by 1, right? Subtract 1. So it's 2 multiplied with the whole big variable, multiplied with 1, right? So it looks like it's already a lot more direct already. You guys with me on that then? But then this is actually not quite there yet. The truth is, and now I'm just gonna have to simply tell you because you're gonna need to wait until a more advanced class to see why it's like that. But the truth is, I need to multiply, aside from that, I need to multiply it with a 4x. Okay? I need to multiply with a 4x. You see, we already found with the foiling, when y equals 2x squared minus 4 and after all squared and all that, right? What was our derivative that we found using foiling? You guys can quickly recall that from me. Okay? It was a 16x
squared minus 32x.
Okay. There you go. Square.
You're right. It's cubed.
It's cubed, right? And then what?
Minus 32x.
Minus 32x. We have an answer, right? So kind of like let's use that as a reference here. My point is that if we didn't do this and believe that this was the answer, was it really the answer? It's only now multiplying that through right there, right? Power 1 anyway, that means there's no more power. We just multiply that through, making it 4x squared minus 16, right? We're quite under the actual answer, you see what I'm saying now? Okay? We're not quite there, right? Because we already found the answer before, and so that rings a natural bell for us, rings a bell naturally for us that this is not quite the final answer yet, right? And so the truth is that it needed an additional 4x right there. See what I'm saying now? So, because now with the 4x here, we additionally multiply things in, right? And we got, yes, it all comes out 16x to the third power, right? Minus a 32, right? X. That's so, and that agrees with the answer we already obtained. So, now we want to know what explained for that. You know what I'm saying? What explained for that? Okay. So now let me clear this out. So the truth behind the scene is that there was a rule. You see what I was doing here? The way how I recognize it. The whole, everything I put in brackets up to this point right here, before multiplying by that 4x again, the whole thing here, I see that as the derivative of the function f. Okay. That taking g as one entire variable. You see what I'm saying now? Because the f right here was recognized as the x squared function. So the action that I took here simply just took the derivative on the squaring function right there, right? The power rule on that f of x function. You guys following my point right there? Okay. So that was not enough. So now what we did here is we multiply with the 4x. See where does that come from? The 4x here is the derivative. This is g. Okay? And coming into here, it is indeed g prime of x. Okay? And so the way how I have been telling my students, this part right here is the derivative of the outside function. That outside function, we took the derivative, right? We're keeping the whole big variable inside of that, and then we multiply with the derivative of the inside of here. Right? So truthfully speaking, it's from the outside, right? It's from the inside. Right? So that rule right there is called the chain rule. What we do is, see, the rule that we're looking at right here. So the rule that's used here is called the chain rule. Sort of like we got one function going inside another function and taking an overall derivative, right? We got to chain the two derivatives together, the derivative of the outside and the derivative of the inside. We chain them together by multiplying them. Okay, that's how it's called a chain rule. So let's formally write it down what it is in the chain rule here. So the whole idea of the chain rule is like this. Anytime your function is in the form of an outer function having composed of another function inside of that. See, that's what happens to our 2x squared minus 4r squared. And the r squared is the f function being the outside, and the 2x squared minus 4 going inside. So anytime we're asked to take the derivative of something like that, right, some composite function like that, the chain rule says you can just simply find the derivative of f, the derivative of the outside function, but keeping g inside exactly the same way it is. But then don't forget, we must multiply with the derivative of the function from the inside to get the derivative of g. Okay, and that completes our chain rule. Okay. And so in that way, well, there's actually a shorter version of that. So for short, here's how I'm seeing it. See, f composed of g, right? F of g. F circle g, you guys remember this famous symbol over here? Back from pre-calculus 1. F circle g, right? Because f of g, that circle came from f, right there. F of g. Okay? When you take the derivative of that, The outside function is the f, the inside function is the g. So here's how I'm seeing it. Chain rule says f prime derivative of the outside multiplied with g prime multiplied, right? With the derivative of the inside. Right? That's the short version of the chain rule. Right? Okay, so that's our example one. We want to find f prime of dy dx. So how about part A here? Let me bring back that what if problem we had earlier. How about what if our function is y equals to 2x squared minus 4? Does that look familiar? Okay. Now instead of squaring that, we're going to raise to power 100. Okay. So making a connection with that earlier demonstration problem, you see the point now is that we don't want to FOIL out, right? Because who's patient enough to FOIL out and take your time for that? And I'm not going to go that route. It takes well over 50 minutes for that, right? So here's how I'm seeing it. So for this function, I mean in one day, this will become the thought process, because right now you guys are developing it. So I'm asking you to write it down on your written work. But like I said, one day, when you get out of the class, or maybe just a few weeks later, it's gonna become something that stays in the scratch work level, or this thought process only. But think about, okay, in this function, do we recognize an inside? Okay, see what I'm saying? Huh? So the way how I see it, recognizing an inside, a lot of times it's more like we choose it. See what I'm saying? We make our own choice again. So you can go with the whole g of x here being a 2x squared minus 4. See what I'm saying? Okay. And why am I saying that we recognize the inside? Because once we recognize the inside, whatever applies on top of this, we call that is the outside. Okay. So what applies to this whole, the 2x squared minus 4, is the power 100, right? That's being applied to that 2x squared minus 4. And so in that way, I'm seeing the outside here, see, because quickly as some scratch work right here. See, so once we call that, then our expression becomes a g of x, represent the whole 2x squared minus 4, right? Being raised to the 100 power. The 100 power is where I see that as the outside of it, because it's another operation raising to a 100 power operation. We recognize that as the outside function. So now along that way, the outside function here, I see some f of capital X, right? Being the x to the 100 power. See what I'm saying? Right? So we start out by recognizing the inside first, and a lot of times, this is where it takes experience here, but so from now I'm showing that to you. Okay, and then you keep working on your assignment and it will get better here. See what I mean? Well, before I go too far, think about it. I said the inside, you recognize it on your own. A lot of times people can think as simple as x. The x can be just the inside function. But then is that really useful? Because if the x is in the inside, and think about it, your whole function, we apply 2x squared minus 4, right? Over to the power of 100. So you can take the whole f of x right here being the outside. You're not helping yourself. Are you understanding what I'm trying to say? Okay? So choosing an inside, we kind of pick a complicated expression, right? That looks complicated enough, right? And then outside of that, there's some operation, some other level operation applied on top of that. We call that is the outside. But choosing something like this, technically it's not wrong. Technically it's not wrong, but it's not useful. Okay. All right. So now once we have chosen the inside and the outside, here's how I'm seeing it. Here's how I'm seeing the power, the derivative is going to work. First of all, my y right here is 2x squared minus 4 to the 100 power. Right? I'm seeing that as the f of g of x. So the derivative times the y dx, right? The chain rule says you need to take the derivative of the outside, so it doesn't hurt to write it down for the first few times that we're doing when we started. The derivative of the outside, right? Multiply with the derivative of the inside. That's what the chain rule says. And so now, what's our outside function? That's 100 power, right? So when we take the derivative, the power comes down. See what I'm saying? Right? The big X is here, but we don't really need to throw in the X. The whole inside of that we recognize being the g of x here. I put that inside 2x squared minus 4. That's forward. And the power of the outside we use down to 99, right? Because the power minus 1. So that took care of the derivative of the outside. And then we need to multiply with the derivative of the inside, so we got what? 2x squared, taking the derivative, making it 4x, right? Constant term becomes 0, we have to simply 4x. And so yes, at this point right here, our derivative is completely done. dy dx equals, now let's multiply all these through right here. So we got 400x, right, times the 2x squared minus 4, all to the 99 power. So that's how I apply the chain rule into doing this work here. And it bypassed completely all of that ugly looking foiling work. All right. Ready for getting in? So, for this function, for a function like this, think about we can algebraically, so f of x here, you can rewrite it as, it's a quotient of 1 over some expression inside a high power, right? Some expression with an inside a high power. But it's good thing is it's just a 1 over. So can we write it as a 4x squared plus 3x plus 1 with all raised to a -5 power? So it's just the algebraic re-expression of that, right? But now from here it leads us, it helps us better to determine, to decide who's the inside and who's the outside. See what I'm saying, huh? So why don't you guys rely on your own natural sense then? What do you suggest to be the inside? Anyone? Yeah?
G of x equals 4.
There you go. So g of x is suggested, right? 4x squared plus 3x plus 1. I wouldn't say right or wrong, okay? A lot of times, you see, the point is once you pick your, or once you chose your inside, then whatever else that apply on top of that is called the outside. And what matters is will it work well or not, it won't work. If it doesn't work well, we choose a different inside. That's all it is. That's not really a right or wrong, people are saying, no? So it's all about, hey, we choose to go in this direction. If it doesn't work, we choose another one, okay? So now from this one, if we chose that to be the inside, think about the outside right here, right? The outside is just going to be some function that's raised to the -5 powers. You see what I'm saying now? Right? So your f of x is going to be that. Simply because, see, once you have chosen your g of x to be, and by the way, I shouldn't use the f here because it was already used for the overall function. How about h of x? But in the way how I'm seeing it, see, what we have here is once we have decided the g of x to be all of that here become the g of x, then your function reduces down to the whole g of x being raised to a -5 power. That's why I now see that, hey, let's call the outside h of x, right? Being the x to the -5 power. So now in that way, so once we've had a clear foundation of that, things will go quite well. So our function f of x in the end, right, is really some h of g of x. We put the g inside of the h, right? You guys will do that with that. Okay. So the chain rule says, taking f prime of x, right? The chain rule says it's, see, just write it down together. H prime of g of x, meaning we take the derivative of the outer function, whatever function that we recognize as the outer function, take the derivative of that. But critically important to keep in mind that you keep the whole g inside the same, right? And then you multiply with the derivative of the inside. Okay. So now here's how the actual work. So outside function is going to be, when we're taking the derivative, that -5 multiplied down in front, right? Making it, so f prime of x, you got -5 multiplied in front. The whole g of x stays the same. So 4x squared plus 3x plus 1. The power on this entire thing becomes what's -5 minus 1? -6, right? And then now that takes care of the derivative of the outside. Now I'm going to multiply with the derivative of the inside. So term by term, we can take the derivative of these guys. So 4x squared, taking the derivative, becomes 8x, right? 3x, taking the derivative, becomes 3. And then that term becomes 0. But so from this, at this point, we are officially done with our derivative. And then there's some negative power, so be watching out for, you may be asked to, write your final answer without a negative powers, things like that. So you can write this as a the whole answer, you can rewrite it as minus 5, right? 8x plus 3, and divided that by 4x squared plus 3x plus 1, all to the 6th power. That's another way of writing your final answer, in case you were asked to write your power, your functions without the negative powers. So let's keep trying into it. It's all about being comfortable with recognizing the inside and the outside, right? And I put in these example problems here from the level of, the easier and then getting harder and getting harder. Okay, so part C of the example. And there's x cubed minus 4x plus 1. For this function right here, from the start, it's useful that we write it as x cubed minus 4x plus 1. The fifth root right here raised up to a 1/5 power. Right? So once again, does that make it easier to recognize where the inside and where the outside is? Because we got the whole x cubed minus 4x plus 1 being trapped inside the 1/5 power, right? Anyone would like to suggest the inside expression? Yes?
X cubed.
That's x cubed minus 4x plus 1. I agree. I mean, I shouldn't even say agree or not agree, right? If there was really right or wrong. Let's go with your suggestion, okay? If it doesn't work, we try a different inside. Okay. So from this inside that was chosen right here, how do I see this? If that's all that here is regarded as a g of x, so the whole thing here, you got g of x here is being raised to a 1/5 power. Right? So it's good to see that, hey, it's good that we recognize after the suggested inside of here, it's good that we can see there's now a capital F, f of capital X, right? Being what? Whatever the input is, right? Being to the 1/5 power. So it seems like it's working well so far, right? Our outside function seems to be like some easy to recognize function. Okay? So now, when you get into it, okay, so again, when you have f of g, right, your y here, right here is the f of g right here. So taking the derivative f of g, it says that we take f prime, right, but keeping g the same, okay, and multiply with g prime, right? You know, familiar with that? So f prime, the outer function, f prime keeping g the same means what? Well, it's just a 1/5 power multiplied down, right? That's what f prime is, right? So 1/5, keep g the same, so g is x cubed minus 4x plus 1. Right? So 1/5, now the power here is 1/5 minus 1. You guys agree? And then we multiply with now the derivative of the inside. What will that derivative of the inside be? Anyone? You should become the expert by now. 3x squared minus 4, right? There you go. And then 1/5 minus 1? Yep, negative 4/5, right? So the final answer comes out, so it's a 1/5. And then you got x cubed minus 4x plus 1, right? Negative 4/5. Multiplying that with the 3x squared minus 4. Yep, we got the derivative down right here. Okay. What kind of function did we just learn about recently? Like to find the derivative of those functions, which function did we just learn recently? The trig function, right? Yeah? Okay. That's where the whole fun comes in here. So how about y equals sine of x cubed plus 4? Sine of x cubed plus 4, and that here is making it very clear to see where the inside and the outside is, right? Because the inside is just easy to suggest. You can check the whole g of x here being the x cubed plus 4. See the entire everything that's inside your sine function. You take that as your the g of x. Okay. So from that way right here, that I chose the inside, and what should the outside be? The outside got to be consistent with the inside to make the whole picture over here. So the outside function f of capital X, right, has to be the sine of capital X. You guys all with me on that still? Okay. All right. Now, upon recognizing, so you can see that our y here is y sine of x cubed to the plus 4. It's the same as f, right, of g of x inside. Right? So your g is here, and your f is there. That's the outside and there's the inside. Yeah. That's just extra notation to make it real clear here. Now, again, the chain rule says anytime we're taking the derivative of a composite situation like this, right? You need to go f prime, keeping g the same, right? And multiplying with g prime of x. Are you good with that? And so now into this property here, using that. So the derivative of the outer function is simply the derivative of the sine function, right? What's the derivative of sine function? Cosine. Yep. So f prime here is going to be cosine, okay? Because that's the derivative of the sine function. You guys all with me on that? But then cosine of what? Cosine of the whole x cubed plus 4, right? Not just simply cosine of x, right? The whole x cubed plus 4. But now, well, that's only half of the story, right? That's not the end of the story yet. So now we're going to take the derivative of the x cubed plus 4 here, which gives me what? 3x squared. You guys all followed? Okay? So that's how we complete our final derivatives. So dy dx turns out, right? 3x squared cosine of x cubed plus 4. Yeah. I should have had that dy dx notation for you. The dy dx in our situation is the derivative of that whole composite thing. Now the thought process here. Anyone would like to suggest an inside function? Yes?
Sine of x.
Sine of x? Okay. I'm not saying yes or no. Let's just take it, right? See if it works. So he suggested sine of x. And let's see how it works. So now if the inside is chosen to be sine of x, and the outside right here, what do I see? Yeah, it's a cosine of, right, some g of x. See how I'm writing that out? That's the same function, right? But we call that g of x. So now it's going to be cosine applied outside of that g, right? Cosine applied to that g. And so that means what? It's now naturally that we choose the outside is the cosine function. You guys agree? So now I'm not going to even beating around the bush anymore. You guys have seen the action so many times. So the derivative, the whole thing, right? We need to take the derivative of the outside, right? What's the derivative of the outside? The outside function right now is a cosine. So what's the derivative of cosine?
Negative sine.
Negative sine, right? So you got negative sine. But make sure to keep the big x right here, right? Make sure to keep that as your original g of x. Okay? So that means what? You stump that sine of x inside, right? You guys follow that together? Okay. And now the derivative, the sine of x inside right here, we have to take the derivative of that and multiply it in. So what's the derivative of sine? Cosine, right? Okay. That's good. And that's how we're done, right? Now, I told this to my the pre-calculus 2 student, but the same for you guys here. This is not sine times sine, okay? This is sine of the sine of x, okay? Because eventually someone is, I keep having students, I hope you guys don't, but I keep having students mistakenly to multiply that with sine right here, making it a sine squared. It's not like that. See what I'm saying now? Because the sine itself, just the sin is a meaningless expression, okay? It gotta come with something because it's an indication, it's an operation that applies on top of something, so you gotta have that part inside of that. Otherwise it's meaningless. Okay? So in other words, my problem here is all done up here. We got the minus, you can rewrite it minus the cosine of x, right? And then times the sine of the whole sine of x in here. Sounds good? Okay. But that's our final dy dx. Right? So let me bring in another example, a couple more kinds of problems here. So example 2, I still want to find the derivative prime of x, or right? As the notation dy dx. Okay. And then the function we have here, how about y equals x cubed plus 3x to the 8th power, and in product with 4x squared plus 5 to the 7th power. Okay. So go ahead and spend some time writing it down. All right, so ready for getting it? So with this one here, you need to notice there is a product right here, right? So this product right here, we got to bring in the product rule. So yes, the derivative that we're about to find, right? X cubed plus 3x to the 8th multiplied with, right, in product with the 4x squared plus 5 to the 7th. So now, again, that's to the 8th there today. So taking the derivative here, as I was planning earlier, we are going to use a product rule first. Because you can see that as far as the order of operation, then, well, these highest power, in terms of the order of operation, these highest powers have to come before the products. But now when we take the derivatives, right, the lower that order of operation, we have to take care of that first. And so in that way, right here, the products rule says we can take one separate derivative on that x cubed plus 3x all to the 8th power, right? That's, take the prime of that. We multiply with the other part in the product, 4x squared plus 5 to the 7th with no prime. Okay, and then we're going to add it. We're going to add that with so how about x cubed plus 3x to the 8th power. Okay. And now I'm going to multiply with, so there's a 4x squared plus 5 to the 7th. I'm going to take the prime of that. So you see, in this product, I'm seeing that there's some p of x right here, right? And then including the 8th power, and then there's the entire q of x right here, including the 7th power. And that's why first thing I fired up was the product rule right there. Okay. So now continuing further with the product rule. Okay, continuing further into the product rule, then that derivative itself, this is where we bring in the chain rule right there. So I was saying when we started out learning about the chain rule, so chain rule is considered as one among those universal rules because it can be used together with other universal rules as well. Anywhere you see anywhere you see that you can apply the chain rule, right? We have to bring it in. So for this derivative right here, it's going to give me, see, we bring it down, and that's similar to example 1 that we've done from our previous lecture. We got 8 times there's the x cubed plus 3x, right? Now we reduce the power by 1, so making it power 7. But don't forget, this is now the inside, so I'm going to multiply with 3x squared plus 3 being the derivative of that. But then don't forget, in the bigger picture, as part of the bigger work right here, then we still playing one part of the product rule. So there's still that 7th power of the 4x squared plus 5 that need to be included. So there's in parentheses 4x squared plus 5, right, to the 7th power. Right, so that first term that I'm writing here, that first group of products right here I'm writing is just to take care of the first term in our product. And then don't forget, we have to add, right, and I'm running out of board space right here, so I'll write it down in my next line right here. So now let's take care of the next one here. Now the 8th power where the x cubed plus 3x being inside of that, we keep that the same, right? No prime. So we got x cubed plus 3x to the 8th. But now with this one right here, yes. Taking that the derivative on that high power 7, right? There's once again, there's the inside function being the 4x squared plus 5. Right? And then there's a outer function being the 7th power. So now chain rule again to be applied. We have 7 times, and then there's a 4x squared plus 5, right? The outer power, we reduce that down to the power 6. And then make sure to multiply with the derivative of the inside here is going to give me 8x. Right? Give me that. And the constant term goes to 0. Right? And so as far as getting the derivative down with that, we're done with that. Okay? And with this problem right here, I mean, technically we can reduce it, but we don't want to FOIL out these high powers. So let's keep those the same, but at least there's something else we can do right here, like the 7 and the 8, we can multiply it as one bigger coefficient, right? So let's rewrite the terms one more time right here. Even though I'm not going to ask you guys to FOIL out, and a lot of times we're not required to FOIL out something that high with that. So it's 8 times there's the x cubed plus 3x to the 7th powers, right? And then there's a 3x squared plus 3, right? And then 4x squared plus 5 to the 7th, okay? Plus. And then, so 7 times 8 is a 56. So we got 56x, right? Multiplying that with x, x cubed plus 3x to the 8th power, and multiply with the 4x squared plus 5 to the 6th power. So for the in-class learning, I'm okay up to here. I'm okay here. That's to be our final answer. But as a matter of fact, in a little bit of a deeper algebra level, then I hope you guys realize one thing. Let me write that here so that you have a better look at that. So we got the, so we have two terms, right? There's 8, and then there's the x cubed plus 3x to the 7th power, right? And then there's a 3x squared plus 3, right? And then there's a 4x squared plus 7, plus 5, right? To the 7. And then there's plus. I really have to write it all laid out, I guess, so that you guys can recognize some further algebra that can be done here. So 56x. And then there's the x cubed plus 3x to the 8th power, right? And we multiply that with there's the 4x squared plus 5 to the 6th. Now, be ready that you may also be asked. You see, there's a common factor over here. Yeah. These two have got common factor. The highest power for that factor is the 7th, right? Among the two terms, because addition is here, so that all that here is one term, all that here is one term, right? So you got a common factor. You also have a, see, right there, right? Common factor. And so the real truth behind the scene is, and also there's that 8 right here being part of the factor as well. So you could have factored out 8, right? There's x plus 3, x cubed plus 3x to the 7th. That's common factor. And then the other common factor, the highest power here is the 6. So we got, the lowest power there is the 6. So 4x squared plus 5 to the 6th power, we factored out, right? And then what's left behind in a huge parentheses is now, I'm looking at, there's a 3x squared plus 3, right? Multiplied with one factor of that remains. Am I correct? Okay. So 4x squared plus 5, right? And we added that with, so now factor out the 8 already, we got 7x left over, right? And then factoring out 7 factors of that already, so we have x cubed plus 3x to the first power, and then that's completely gone. And then you can take your time foiling these out and then combine like terms and all of that. See what I mean? Okay, so be ready to do those kind of algebra things like that. So in this example specifically, I don't want to get too far into that, but be ready for things like that may be required, right? In some of the problems that happen here and there with indicated instruction. Am I making sense? Yeah. Okay, so it's all about it's at this point, I hope you guys keep getting more convinced that the massive amount of calculus we learn, 95% of that is the algebra, right? And the calculus is just about the 5% of work of new theory that we added on top of that. See what I'm saying? Like the limit concept, like heavy part is the algebra, and then the limit concept, when the algebra is done, right? The limit comes in easily, and then the derivative is the same way. And we got to play along with the algebra, and then we take the derivative. Okay, but that's just like I said, something for you to open your awareness. Okay. So, how about let's look at part B of the example. We got f of x here is written to be cubed plus 5 all to the 10th power. Okay. Okay, so ready for getting in again? Okay, so when we're observing the operations involved here, so I have a high power, right, being the outside right here, and then inside of that high power there's a sum function, right? And so very easy that we can recognize we should use a chain rule over here, and chain rule this time for this problem here comes first in line here. So my derivative will come out, because definitely we do not want to FOIL this out, right? Or do whatever, because it's a very high, crazy high power right there. So chain rule says, you see there's, for a problem like this, make a quick note here, we can easily take the whole inside here being that g of x to be the x squared plus 4 over the x cubed plus 5. So that's your g of x. Yeah. See what I mean? And then so that means your outside function will consequently be, so how about h of x right here, right? The outside function being the whatever to the 10th power. So the whole thing here is the g being stumped inside of the h. Okay. So you guys follow with that once again? Okay. And so now, so after that extra note right there, then so f prime of x, right? In the end, now it has to be, the chain rule says we're gonna take the derivative of the outside right there, right? So that's making it 10, right? To the 9th power. See, you see the structure of the derivative of the outside function right there? And then the whole big thing inside remains exactly the same. So we stump the whole quotient there, x squared plus 4 over x cubed plus 5. Okay. So that's the power rule applied on top of the outer function. Okay. But now when we get into the derivative of the inner function, right, of the inside function right here, then what rule are you guys thinking about? The quotient rule, right? The quotient rule is what's happening here, because there's a quotient. So we gotta use a quotient rule. And so the quotient rule says we gotta take the derivative of the numerator first, right? So, well, just write it. It doesn't hurt to document as much as you can. Even though I'm starting at that point, at this point of your learning, I'm starting to allow you guys to rush your step a little bit, or to combine multiple steps together. But it's always good that to document as many little steps as possible. So in case there's errors come out, it's easier for me to step in and trace out where the errors come from. See what I'm saying? No? So x squared plus 4, right? So you might plan it just to write down, hey, we are about to take the derivative of that. And then I'm going to multiply that derivative with the x cubed plus 5, no prime. You guys will be there? Okay. And then we subtract according to the quotient rule. And we subtract, what do we have here? I'm going to keep the x squared plus 4, the numerator, now without the prime. And then I'm going to take the derivative of the denominator. And then make sure the quotient rule says we have to divide, we have to put in the denominator of the final answer the square of the original denominator. We good with that? Still? So now in my next step, yes, I'll have that. I'm going to leave that 10, and then there's a big crazy thing, x squared plus 4 over x cubed plus 5 to the 9th power here by itself for now. Right? Let's really take care of the little pieces, like the little derivatives work right here, right? Inside of our quotient rule. So what I have now is going to be the derivative of that x squared plus 4 gives me simply a 2x. Is everybody still with me? Right. And then we multiply that there with the x cubed plus 5, right? And then we're subtracting. Now I'm keeping the x squared plus 4 the same. Taking the derivative of the x cubed plus 5 is giving me the 3x squared. Right? And then there's the x cubed plus 5 all squared in the denominator. So officially, this is where we have already found our derivative, right? Officially, that's the point where we already got our derivative successfully down, but let's see if we can algebraically reduce that a little further. Otherwise, it's way too much. So that's a 10, right? X squared plus 4 over x cubed plus 5 to the 9th. And then we got, so 2x times x cubed right there, making it 2x to the 4th, right? Plus 10x right there. And then we're subtracting 3x to the 4th, right? And we're subtracting 12 x squared. Please correct my algebra if you have to. So x cubed plus 5 squared in the denominator. Right? What I have here, square plus 4, right? X cubed plus 5, yeah. Right, so these two combined like terms is giving me the minus x to the 4th, right? But yeah, so we still got the minus 12 x squared and then plus 10x. And so these two terms are here, really they're not like terms. And the x cubed plus 5 all squared. Okay? And so at this point right here, then we just gonna get that done right there. Okay, that's about the best we can go. Yeah, we still have to have some level of simplification. Yes, I understand, because I mean, being able to simplify is actually for your own good at this point. Your ability to simplify is on your own good, because later on, think about it ultimately as a big picture. Why do we do all of these derivative things? Because eventually we're going to substitute the values in, right? And get the slope retention line. So think about if you leave your expression for the derivative this big right here. When it's that big and you're substituting the values in, you're going to have a harder time going through all of the calculations. So being able to simplify it down, it reduces the amount of calculation for you. So that's still always a good advantage. So of course, I won't go too far into the simplification, okay? But we still gonna, it's still better to do some moderate level of simplification with that. The entire intention of my example 2 here is to get you guys comfortable with using the chain rule and being blended together with the other rules we have learned, right? So let's say, how about in part C of the example? Let's look at our function view. How about we got a sine brackets 3x squared plus 4 all squared again. Okay. And he did allow me to change this to, basically look back, how about we change it to 4x? It's a little more fun, that's all. Right? So 3x squared plus 4x all squared inside a sine function. All right, so now getting into this, here's another situation I want to point out here. There's, as far as inside and outside, right? You got, yes, there's an inside, right? Because it's inside of an outer tube, am I correct? And at this point, as think about I keep having students, and if you guys don't have this worry, then that's good for you. But think about in case you got confused all over about who's the inside and who's the outside, just think about the order of operation. The inside is the one that has to be taken care of first. And then, so like in a situation like this, I call this part right here the inside, because if we're substituting in the values, we have to calculate the 3x squared plus 4x first, right? Or at least before the overall square here. See what I'm saying? No? That's why the square here, the squaring right here will be some outside, right? You guys follow it? But then, for this kind of problem, even the trig function is on top of that, right? So even after you take the square here, there's a sign right here that's going to be even the outermost. You guys follow it? So there's a level of function, and then there's something else inside, and there's something even else inside of that. Right? So there's levels of inside and inside of that. Sounds good. That's what it's all about. You stay close with the order of operation, and then which has to be done first, right? Which group of function has to be done first, and then outside of that, right? And then after that, something else can be done, and then after that, something else can be done, right? And so in that way, in the way how I pointed that out, then we actually have two levels of in and out, like that, right? Inside and outside. That's why here's it. When you take the derivative, y dx, right? Then chain rule applies from the outermost end. The way how chain rule works, it goes from the outer end, right? The outside function, and we go back, make our way in with that. Order of operation, we go from the inside out, right? But going chain rule, we go opposite, we go from the outside in. So for here, in how I'm seeing it, the most outer function right here, right, is a sine, right? What's the derivative for sine? Cosine, there you go. So yes, the outermost function immediately turns into a cosine. But see, everything that was inside of the sine, we keep the same, so including, there's a 3x squared plus 4x, all square like that. You guys follow it? And now I'm going to take the derivative of the entire, let me still mark it red right here. The entire part inside, including the square right here, right? Now we'll take the derivative of that. So that part right here is going to give me the derivative. So the derivative now is going to give me, see, so how about, let's just write down the plan right here. 3x squared plus 4x all squared. I'm going to take the prime of that. Okay? So let's move things step by step again, instead of too rushing. When you guys are fluent enough, you can just continue with that. So in my next step, yes, cosine, that's 3x squared plus 4x all squared, right? Multiply. So now the derivative here, there's another level of chain rule being used right there. So there's now 2 multiplied with 3x squared plus the 4x, right? And then the inside here, right, is going to produce another derivative. We have as a 3x, 6x, right, plus 4. You guys see how the chain rule was used sort of like twice there? Because there are 2 levels of inside and outside, and there's another outside, right? So for this problem right here, and so for this one, let's just decide that's done right here. I'm not going to bother too much with having you guys simplify it, because really it's not simplified. You may also bring that 2 in front to make it like the front coefficient, right? But that's not really considered as a simplification, because it's not making things any shorter. Okay? And so for this example 2 right here, with this class of problems where I want to introduce where the chain rule can be used with the other rules right there, we're done with that. So let's move on to another one, another kind of problem. So let's head into example 3 here. Okay. So I keep making that promise that every here and there, every here and then, I'm going to have to give you guys a tangent line problem again, right? So let's just find the equation, okay, of a tangent line. Okay. Tangent to f of x equals, that's 3x squared plus 4 to the 5th power at specifically x given equals 1. All right. And so once again, anytime that we're back to the tangent line problem, right? Coming up with the equation of a tangent line problem. So ultimate goal is to complete the equation y equals mx plus b, and our slope here is the slope of the tangent line, that special slope. That's why I have been writing that as the mtx plus b. Okay. And so the first thing is to get the slope, right? And so as a reminder, so the first thing is to get the slope, but as a reminder now, the slope can be calculated by getting the derivative of the function and then substituting the given value 1 into the function. Because 1 is the given value, the specified value, right? And so now, so in that way, we're gonna calculate the f prime of x, right? So f prime of x for our case here, we're gonna see that's a 3x squared plus 4 all to the 5th power, but we're gonna take the prime of that, and this is where we're gonna start using chain rule again. So chain rule is used anywhere, right? Anywhere that we have to, we use the chain rule. Right? So now with this rule here, it's simple to see that it's going to be 5 times 3x squared to the 4th, all raised to the 4th power. 3x squared plus 4 to the 4th power. And then we multiply with the derivative of the inside, which is the 3x squared plus 4 here. So that gives me 6x. Okay. And then see, there's always a good advantage that, hey, let's multiply this 5 to the 6 here, making it 30x, right? And then multiply with 3x squared plus 4 to the 4th power. And then you can all check my algebra like that. So my derivative work is already done right here, but I decided to make it all a little bit shorter like that, so later on it can save some calculation power for me. Okay. All right, so now that means the derivative is already found. And so now our slope of the tangent line here is going to turn out be again, let's remind ourselves, it's f prime of 1, right? So that means I'm going to substitute x equals 1 into this derivative. So there's 30 times 1, right, times 3 times 1 all square plus 4 raised to the 4th power. We all agree with that, okay? So that's making it as a 30, right, out here multiplied with the 7 to the 4th power. You guys, I need your calculator right there, so go ahead and use your calculator and get me that final calculated answer right there. You guys all bring your calculator?
Do you want me to multiply by 30 as well? Or
Yeah,
just,
the whole final complete slope of the tangent line.
72,030.
72,030, you said?
Yeah.
Okay. And you guys confirm with him right there? Should be simple stuff, right? Okay, so now you got the slope. So what's the tangent point here? Big step 2, right? Easy work, but it's still important. At x given to be 1, right? What's the y value? Y comes out because you're gonna simply substitute that into your x equals 1 into the function, right? You guys agree that? Right? So the function here is yes, it's 3 parentheses 1 squared plus 4, right? To the 5th power, that's making it 7 to the 5th power. 7 to the 5th power, calculator.
8,807.
807? Okay. That means our tangent point here is 1, comma 16,807. Got a tangent point. See that now? Yes, numbers will go crazy sometimes, but see, that's the advantage of having algebra. The more you can simplify your expression, right? The less calculation steps we have to do. Otherwise, if you leave your derivative work or whatever work that's so giant like that, right? When you have to substitute the values in, you're gonna have a hard time typing it through your calculator. Okay. So the last big step, right? We're gonna get the v value. So our equation of the tangent line at this point is halfway completed, right? Y equals the slope was found to be 72,030, right? Times x plus b. Okay. And now I'm going to substitute these two values, I mean this pair of values, right? X for x, y for y. Okay. So I'm making it. Okay. So that now means 16,807, right? Is equal to 72,030 times 1, right? Plus b. Okay. So we can easily solve for b. So go ahead, subtract that, the 72,000 from the 16,000 something from it. Did you guys subtract?
Negative 55,223.
Negative 55,
223.
223. Right, so negative 55,223 for the calculation. All right, so now we have completed our equation. I'm short of space, so I'll write that final equation here. So the final tangent line equation, right? The equation that we found here. So y equals 72,030x, right? Minus 55,223. That's our concluded tangent line. You guys follow it? Right. And for something like this, see, let's hope that we've been doing without algebra error or without calculation error, because even when we use decimals, we're typing something like this. Decimal is going to give us a graph that's extremely hard to recognize, so it's pointless anyway. See what I'm saying? No? Right. So let's just hope that we did. I mean, in the end, it still doesn't violate the overall picture of the work, right? The overall structure of the work. Okay. Any other questions that you guys have for me?